Hi class, today we'll be looking at section 3B, adding and subtracting surds. First of all, let's have a look at your learning intentions. First, to understand that only like surds can be combined under addition and subtraction. So you might heard of like terms, and like surds is going to be very similar to like terms. To know how to add and subtract like surds, and lastly, to know that it is helpful to simplify all surds before determining if they can be added or subtracted. So pretty much this class, we're working out like surds and simplifying and addition and subtraction in the end. All right. Adding and subtracting surd is rather like adding or subtracting algebraic expressions in that you have to collect like terms, which we've done in chapter 1. For example, 7x and 3x are like terms. So 7x plus 3x is equal to 10x. So 7 of x plus 3 of x, we just combine the coefficients. 7 plus 3, 10 of x. All right. Multiples of the same surd are called like surds and can be collected, that is, counted, in the same way as we collect like terms in algebra. This works nice and nicely as simply as what we did for collecting like terms. So root 2, it just means 7 of root 2 plus 3 of root 2. That's 10 of root 2. So you can consider root 2 like a thing, okay? 7 of this root 2 plus 3 of this root 2. And here we go, we've got 10 of root 2. You can collect together any terms involving roots of the same number, like here, the same root 2. You cannot collect together terms involving roots of different number, such as root 2 and root 3, okay? Because they're not like surds, okay? They are unlike surds. Like surds. Like surds are multiples of the same surd. Like surds can be added and subtracted. Simplify all surds before attempting to add or subtract them, okay? And we're going to look at 2 examples provided with procedures. If you find it very easy. Can you add 3 root 2 and root 8? So 3 root 2 and root 8. At first glance, you might think, oh no, I can't do it because this is root 2 and this is root 8. But remember, you can simplify all surds before attempting to add or subtract them. Square root of 8 from your times table, you know 2 times 4 is equal to 8. We want perfect square, so I'm gonna rewrite square root of 8 as square root of 2 times 4. Okay, so it becomes 3 square root of 2 plus root 2 times 4. Remember, we had the formula square root of x times y is going to be equal to square root of x times square root of y. So this could be split up into 2 parts. So we have, so it's back to here, 3 root 2 plus, by applying this, we have square root of 2 times square root of 4, which we like it because square root of 4 is could be simplified as simply 2, okay? This could be simplified as simply 2, okay? But I'm not going to write here. I'm going to write line by line. So 3 root 2 plus 2 root 2, okay? This is 2 root 2. And, 3 of root 2 plus 2 of root 2, 5 of root 2. So your answer is going to be 5 root 2, all right? Make sure you simplify before adding. Okay, next one. And also, before I move to the next one, just a reminder here, you would rather write them line by lines because that's reduces the strain in your brain, okay? But it would be great if you can just do it in your head. Like you see square root of 8, oh, that's 2 root 2, so 5 root 2, you get the answer straight away. That's fine, you get perfect marks. But in your exam, you get marks for working out. So try to show some working out instead. Like even if you got the answer wrong, I still give you some marks, okay? Example 2, can you subtract 3 root 2 and root 7? All right, to do that, we're going to check 3 root 2 and root 7 are like surds. Unfortunately, they are not like terms. They are unlike terms because square root 7, you can't simplify anymore. okay? Because from a times table, you only know 1 times 7, and 7 is not a perfect square. Okay, square root of 7 cannot be simplified. So simplify that. This is already, let me move upwards a little bit. Already the simplest form. All right, example 3, simplify the following. Again, there's no procedure stating here. We just got to record the notes from previous page. You check, are they having the same, are they like surds? Yes, they are. They're square root of 5. So 2 plus 3, 5. Square root of 5 stay the same. You're not adding 5 and 5. It's not 5 square root of 10. Okay, it's not. You don't add in the mid add number under the square root side. That's totally wrong. Totally wrong. Because this is just considered like as a thing. So it's 2 plus 3, 5 root 5. All right, next one. Again, we just click like surds. Square root of 7, square root of 7, square root of 3, square root of 3. So 3 minus 2, 1. So it's 1 root 7. You don't have to show the 1 in front of root 7 because, like 1a, you can just make it as a. You don't need to show the 1 in front of a. And we look at the other parts. 2 roots 3 plus 5 roots 3. So that's 7 roots 3. Okay, so your answer, the final answer is like that. And we know square root 7 and square root of 3, they can't be simplified. So that's your final answer. Example 4, simplify the following. First, click like surds. Okay. So 2 minus 5 is going to give you negative 3. Okay. 2 minus 5 is negative 3. So negative 3 with your surd, square root of 2. And next one, square root of 10, square root of 10, minus 4 plus 1. So it's minus 3 square root of 10. Okay. And in here, they've got the common factor negative 3 here. You could show your answer in this way, but you could also show your answer by factorizing. So negative 3 bracket square root of 2 plus square root of 10. Okay, because we have taken the common factor minus 3 out. So this becomes a plus. You can always check it by expanding it. Minus 3 times root 2, minus 3 times root 10. That's minus 3 root 10. Okay, next one. Again, square root of 5, square root of 5, square root of 15, square root of 15. So my negative 4 plus 2, negative 2 square root of 5, negative 2 plus 5, plus 3 root 15. And here you might be wondering if they can be simplified or not. Okay, 15, record your facts from your times table. 3 times 5 is equal to 15. But both 3 and 5 are not perfect square. Okay, 3 times 5 is equal to 15, but both 3 and 5 are not perfect square. So that's already the simplest form. So here we go. That's your final answer. You can't simplify anymore. Example 5, simplify these surds. All right, 7 root 2. So from before we know root 8 is 2 times 4. 7 root 2 minus root 2 times root 4. So this could be simplified. Root 4 is equal to 2. So 7 root 2 minus 2 root 2. And they are like surds. 7 minus 2, 5 root 2. Okay. Next one. 2 root 3 minus 27. 3 times 9 is equal to 27. So 2 times 3 times 9. And plus 3 times, 12, 3 times 4. So square root of 3 times 4. Okay. So that's simplified. 2 root 3 minus, we can just get rid of it. 2 root 3 times root 9 plus 3 times root 3 times root 4. If you can get the answer straight away from this, if you know square root of 9 is 3, you don't have to show square root of 9. Okay, I'm showing all the steps just to help you understand. So 2 root 3 minus 2 root 3 times square root of 9, which is 3, plus 3 times root 3. Also, you could write this as 3 root 3, because you don't have to show the multiplication sign, times 4, which is times 2. Okay. All right. So 2 root 3 minus 6 root 3 plus 6 root 3. Interestingly, these two are the same. They perfectly canceling each other out. Okay, minus 6 root 3 plus 6 root 3, they're canceling each other out, which gives you 0. So that's 0. That's 0. Okay, so your answer is just nice and simple. 2 root 3. Okay, last example I'm going to talk about. Simplifying the following surds that involve fractions. All right, at the first glance, you might don't know how to do that, but remember these. If you have 3 root 2 or 3 over 2, this is actually like 3 times 1/2. Okay, or 1/2 times 3. You know, multiplication, you can switch the position. It doesn't affect your answer. So similarly here, square root of 5 over 4. This is actually can be written as 1 over 4 times square root of 5. Okay, like that. And square root of 5 over 3 could be written as 1 over 3 and the square root of 5. Okay, I'm gonna box this, make this in the box because that's some side notes. Okay, we're gonna apply this idea here. So we've got 1 over 4 square root of 5, which I got from here, and plus 1 over 3 square root of 5. So they are like surds now. So we just use 1 over 4 plus 1 over 3. I can put the brackets because I know I'm gonna do an extra step on that. And square root of 5. Okay, so let's just work out the coefficient for that. 1 over 4 plus 1 over 3, the least common multiple would be 12. So 3 over 12 plus 4 over 12, square root of 5. So that's 7 over 12 square root of 5. Okay, that's the end of this lesson. And it's your time to complete the question for exercise 3B in your workbook. Okay, thank you.